Okay. So there we go. So they're asking us, is f strictly decreasing on the interval -2, 0? So this is not a hard question if you're speaking their language. So let me help you dial into their language, and then you'll be like, oh, it's a no-brainer. That's all they're saying? So first off, the part of the trick is, maybe the most of the trick even, is this thing right here. Oops, my pen. This thing right there. When they give you an interval, we're so used to looking at that -2, 0 like it's an x and a y, like a point, but it's not. When they say interval, they mean it's an x and an x. That's what's weird. Because it's exactly the same way you would write like a back 2 up 0 kind of xy point on a graph. The only reason you know it's not that is they use the word interval. So when they say interval, they mean from back to like right there, back to 0, like right there. They mean on the x-axis in that zone. That's what they mean. From back 2 to 0, x and x. Both are x's, not xy, because they said the word interval. That's the only way you know that. So basically they're saying, hey, bless you. So they're saying in this section of the graph, and they want you to go up to the blue graph there, So really they mean that little piece. You know what I mean? That's what once you're dialed in with their language, you're like, oh, okay. So you're asking me that little piece of graph between x is -2 and x is 0, is that strictly decreasing? Meaning, is it going down? Yes is the answer. Now, you might think, wait a minute, sir, but if you go that way, it's going up. What do you mean? Right, so you're right. If you're thinking that, you're totally right. So we have to, because any line goes up and down, depending, or curve or anything, depending which way you're going on the mountain, right? A mountain goes up and down. So we have to agree, in math, you probably already know, it's as we go to the right, huh? So we mean, is it going up or down as you go to the right? So if you go from left to right, this mountain's going down. So yes, it's decreasing. Make sense? Once you get the language, I think it's easy, huh? That's all they're saying. All right, so okay. So they're saying, is it strictly increasing on -5, 0? So again, that's an interval. So that means we're talking x and x, not x and y, because the interval on the x-axis they mean. So that means from where? Here's -5, and then here's 0. So they mean in this section. So in other words, this part of graph, right? They're saying, is that piece of graph strictly increasing? Is it just going up? So if you're on the roller coaster, riding the roller coaster, are you going up the whole time? No, you're going down the last part of it. So it's not strictly increasing. It's kind of going up and going down in that section, isn't it? So you'd say, no, it's not strictly increasing. So once you know what they're saying, it's an easy question. Okay, so list the intervals on which it's decreasing. So they want us to give the x intervals. So let's do what do they say, decreasing? Let's do the roller coaster thing here. So I'm going to if I'm riding the roller coaster, in this section, I'm going up, 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 and here I'm at the peak where everybody screams, and then you go down. That's a decreasing section. From where to where? Oh yeah, they said -4 here. If I erase that, you can see I wrote over it. Yeah, negative, see the little x there? You guys are right. The x value is -4. So that must be at -4. It begins there. That's the peak. From -4 all the way, and this is what? +4 right here. So from -4 to +4, it's dropping. So everybody tracking with me on that? So from -4 to +4, it's decreasing, right? And then it starts going up, up, up. Well, the rest of the way it goes up. So it's only decreasing from -4 to +4. Again, those are both x values because it's an interval on the x-axis. They want to know what x section is it decreasing. Is that good? Does that make sense on that? All right. By the way, good question. Sometimes people ask me, should we put brackets on those? Honestly, I don't care on a test because, what is it really doing right at -4? Well, it's a point. It's not going up or down right at a point. So it doesn't really matter to me whether you include the endpoints or not. I don't care. I think Math Excel wants it that way. I'm like, yeah, I'm pretty sure they want it that way. On the test, I don't care. It doesn't really matter. You're just saying what section. You're not being specific about the edges with that kind of a question. Try this one. Okay, so it's saying list the values where there's a local max. Okay, well, it's right there and right there. I think you probably know. Those are what we call the local maxes. What we mean, why we say local, is because those might not be the overall max. Max just means highest point, right? Because this curve may eventually go way up. I don't know, it may come down again, who knows. But even if it does, my point is, even if it does go rocketing up afterwards and these values are way higher than these guys, meaning this guy right here and this guy right here, are still local max, meaning they're the biggest in their locality, in their vicinity, right? Stuff right around them, right? That's like being a hero. That's like being an academic hero at your junior college, but then you go away to the UC, and it's a different story, right? You could be a hero here at Fresno City College, ace in all the classes, but UC Davis might have a little more competitive pool. So anyway, so that's what we're saying. This is a hero in his vicinity. He might not be the overall big. So we call those local max. Those are a local max points. So they want, what do they want here? They want type an integer. Okay, so notice they don't say ordered pair. That's when they want the parentheses, with the two numbers and the comma. They don't say that. They're not saying ordered pair. So they must just want the x values. What, can you guys tell? I'm having trouble seeing on the graph. Is it 4? I think it's 4. And is that like -4? I think. Oh, no, I don't want that one, do I? What am I doing? I want this one. What is that other one? 12 or 13 or something? 12? I can't tell. On Math Excel, you can blow it up and you can see the line. Oh, you can't even see lines on it. There's lines on here. It's not showing them up very well. You can find all that on your own, no problem. Oh, no parentheses. I just went over that, huh? No parentheses. You can put them in any order. Oh, +4. Doesn't matter. You put the 4 first and the -12. Doesn't matter what order. There's 2 answers with a comma. You don't need to put that plus sign like that. Just regular 4 is good enough. It doesn't matter. Good? So whatever those spots are, they just want the x values only, where those local maximum values occur. That's right, there's some graphing calculator ones. You guys have your graphing calculator today? I think we need to go there. I'm confident we do. All right, so let's answer this one first off. So, it's off the screen, huh? It's on that screen. Look over there. I don't know why. I used to complain. I used to call the tech guys, hey, my projector's off. They used to come out. I think they were tired of hearing from Mr. Heron. And then it just goes back. So I don't know. One day it's on, one day it's off. So I gave up calling them. So it just kind of moves on its own, it seems like. So all right. So you can look over there. I don't know why it's not. This projector's off a little bit. But we're looking at that graph, and we're supposed to determine first off what are the intercepts. Now, what are intercepts? What do we mean by intercepts? Hits the grid lines, the axis lines, right? So that'd be like. What did just happen? There we go. So that'd be right here, and right here, and right here. Whoops, I didn't do that one very good. Right there. Those are intercept points, right? You can see those 3 dots. So they want those list intercepts, and notice what they say here, ordered pair. Remember that phrase? That's the parentheses, comma, 2 numbers. They want the x and the y. Ordered pair always means x and y when they say that. Ordered pair. So let's list them. What is this one right here? Back 1. Up 0, comma. The next one, what's this one? Doesn't matter what order you put them in. +1, 0, and then what's that one? Over 0, up 1. So there's the intercepts. Good so far? Let's keep moving. Part B, domain and range. Okay, domain and range. Remember, on a picture, and you get the hang of this domain stuff, they've asked us domain for an equation. That's when we look for trouble spots, like inside the square root or denominator. When they say domain of a picture, that's when we go width, and range is height. So on a picture, the domain would be how wide, left edge, right edge is the domain. That's what we mean by domain. Okay, so what is the left edge here? What's the right edge here? What's that, -3 to +3? So the domain, so I'll do part B here, domain is, this time the edges do matter. We care about, does it get all the way to that -3? Yeah. Straight, see the solid dot at -3? If that was an open dot, then it wouldn't quite hit there, and I would put a parenthesis by the -3 saying it doesn't quite hit straight on, it just gets close. right? So I'll round the, so it's straight on that, and then it's, oh, that's it, that's the domain. And then what's the range? So the domain is left to right. Remember range? Range is like here, yeah, bottom to top, yeah. Range is bottom, comma, top. Again, bracket. What's the bottom? What's the lowest? We're looking at the y-axis here. What's the lowest this graph goes? Yeah, 0, huh? Yeah, 0. Highest it goes is what, 3? It's bottom to top, 0 to 3. Brackets again, it hits. Solid dot, right here at a height of 0. Solid dot up here and over here at a height of 3. All right, part C. Intervals on which it's increasing, decreasing, or constant. Okay. So now, what are the intervals? The section, intervals again means x with x, doesn't it? So interval, whenever they say the word interval, we're talking x with x. So we come over here and we say, okay, what are the intervals as you're walking on the x-axis over which it's, let's do increasing first off. It's increasing. If you're on this was a roller coaster. Here you're going down, then you go up, then you go down. It's a wild roller coaster, then you go back up. So when are you going up? Up, and we're talking about you go from left to right, always. Yeah, from here, negative, whoops, kind of be a little more clear here. So from here to here, -1 to 0, you're going up. And from, right? And from here, 1 to, what's that, 3? And from 1 to 3. So from -1 to 0 and from 1 to 3, you're going up. This section and this section. Good on that? And again, I don't care on intervals, I don't care brackets or parentheses. Because an interval has nothing to do with the edge. You're just saying what region, what section am I going up or down in. I think Math Excel wants parentheses, but I don't care on a test. Decreasing, what are the sections in which it's decreasing? Well, the other section is going down here, and it's going down here. So that's what, -3 to -1? I'm thinking, is that what it is? Let me erase all this. -3 to -1, yeah, -3 to -1, there, and there. That's what, 0 to 1? 0 to 1. Again, we don't care about the edges, right? You see the difference? Is that confusing for you? You see, domain and range, I care about the edges, whether they're in or out, because I'm saying what exact x values does the thing exist at for domain and range. So I care whether it actually exists at -3, right on the money, right? Is there a solid dot at -3 or is there not? That matters. But when it comes to where is it going up, do you see that one individual point doesn't matter? How can you be, like think about me, I'm standing at this point, right? Well, what if I was walking on a slope here, right? What if I was walking on a slope? Imagine that this room was tilted, and I'm walking on a slope, right? If I stop, and I go, hey, right now, I'm stopped. Am I going up or down? You're stopped. You're not going up or down. That's why an individual point doesn't matter for increasing, decreasing, right? The edges don't matter. It's just it's a motion, not an edge. It matters. All right. So, final question: is it even, odd, or neither? We haven't talked about that, have we? So let's talk about that. Even. I gotta have some room. Let me erase this stuff. So even. Does anybody know it already? What's even? It Yeah, exactly. It's like that. It's the same. It means that both sides of the y-axis. It's y-axis symmetry. Remember how we talked about y-axis symmetry? Was it Thursday or something like that? Y-axis symmetry. That's called an even function. An odd function would be a function like this. No, it wouldn't. No, that's x-axis symmetry, but that's not an odd function. I'm getting confused. An odd function would be something like this, for example. Odd means origin symmetry. So it's just new words for stuff we've already learned. Remember how we've talked about whether a graph has y-axis symmetry? Symmetry means same, right? Same on both sides of the y-axis. That's called an even function. Why is it called even? What is that graph? Y equals x, even power. What's this graph? Y equals x. Do you recognize that? We'll do it this week. We'll go crazy with this week later on. But yeah, odd power. That's why they get the names even and odd. Because odd power ends up having what's called origin. Now, you remember origin? That means 2-quadrant rotation, or halfway around, 180 degrees rotation. That's origin. We don't have a special name for the x-axis symmetry. We just have special names for the y and the origin, even, odd functions. So they're asking us, they're saying, hey, this one you got here, is this one an even or an odd or neither? You know, some graphs are neither. Probably most graphs are neither. So is that one even or odd? Does it have a symmetry? In other words, they're asking. Is this graph the same on both sides of the y-axis? Does the right and the left of the y-axis look the same? Sure. Yeah, the y-axis splits it right in the middle, huh? That one's got y-axis symmetry, so this one is even for that reason. Makes sense on that? So just new words. You can put that in your 3x5 card. No need to memorize that. You get 3. Of course, I'm starting to say that for everything, aren't I? There's no more room there. But you can write even, y-axis symmetry, odd, origin symmetry, and put little example pictures. Questions on that before I leave it? All right, let's answer just that part. Okay. So for this question, let's answer just the domain. I think the rest will be simple for you. X-intercepts, y-intercepts, even, odd. That one's neither even, can you see it over there? That one's neither even nor odd. That one has no symmetry at all, huh? Anyway, but here's the one thing I want to answer for you. Let's do domain. Give that a try. What's the domain of that? You can see it over there. Oh, yeah, that part's easy. It's the range I want to talk about. Yeah, you're right. Yeah, the domain is, left edge, right edge. Yeah, you're totally right. It goes left forever, huh? And right forever. You're totally right. So negative infinity range. Okay, so what's the range, though? That's the tricky one. So the range is the height, right? The vertical span, bottom, comma, top kind of thing. Yeah, they're trying to tell you it levels out. They're not being super clear, but see the way this graph kind of levels out? Really what they should put is a horizontal asymptote line. The dotted line, we'll get into that this week even. You probably are somewhat familiar with that already. Anyway, but basically it flattens out, doesn't it? It doesn't keep going down, is what they're saying. It flattens, and then it goes up forever on the other side. Oh, that's what they're indicating. So if it flattens, then the lowest it ever goes is this level. That's the lowest it ever goes, and it goes up, up, up forever. So the bottom is what? 0, and the top is infinity. And it doesn't, it use a parenthesis because, does not hit 0. Gets super close. No, it's height. Yeah, good question. It's not 8. Maybe it is 8. Maybe it is. What is it? Maybe it is. I can't even tell. You're right. It's something other than 0. What do I think? It's not 0.
The intercept is 0, 9, so it's 100.
Yeah, you're right. It's 8. Thank you. Yeah, that's the intersection point they're telling us, huh? They're saying this dot here. Whoops, I can't do it unless I'm more careful. Come on. There we go. Yeah, they're saying this dot here is over 0 up 9. You're right. So this must be a level of 8, height of 8. Thank you. So it's 8. There, I fixed it. 8 to infinity is the answer. It doesn't quite hit that 8. It gets that asymptote line that they're indicating there gets infinitesimally close to 8. Do my hands here. But it never quite hits the 8, like a plane that never quite lands. It just gets infinitely close forever. All right, the rest you can do easy. The rest of our time on is doing these equations and then doing the graphing calculator stuff. That'll take us 20 minutes easy to do a good job on that. So let's do that. All right, so now, if you notice what they're doing throughout this chapter, in the last chapter, they're basically giving us rules like domain and range, and now it's the even odd thing, and they're having us do it with pictures, graphs, and then they're having us do it with equations. Are you seeing the idea? You've got to learn how to do the rules, domain, range, even, odd, for graphs, and then the rules, domain, range, even, odd, for pictures. I said that, for equations. So both. So now it's like, okay, you know the even odd thing, but how do you do it if there's no picture? There's just an equation. Well, let me give you some exact steps. I'll talk about why they're right afterwards. Let's make one big plan. Test for even odd. So the test for even oddness, step 1, plug negative x in for x everywhere. So just put in negative x with parentheses around it. Step number 2. Roberto, you're getting here quicker every day. Did you do like 90 on the freeway today? No.
Did you set like a world record?
Tuesday,
Oh, that's the tight one. Okay, I'm getting confused. Roberto's telling me he's going faster. He has to come straight from some other thing. And he's almost flying. All right. Negative x in for x. And now, then simplify. And step 3, if the result is A, same as original, after simplifying, if it comes out the same as it started, that means you're even. If it's, how do you say this? If it's -1 times original, there, that's the truth, yeah. Negative, if it's the same as the original except times a -1, that means you're an odd function. Otherwise, if it's a mix of those, then it's neither. Yeah, I like that. That's a good, clear way to write that out. Better than I've done before. Yeah, good. So that's the test. That's what you got to do. And there's another thing for your 3x5 card. Hope you can write small. All right. So now, let's give it a try. So, I'm going to take this function, this -5x squared minus 3x thing, and I'm going to plug in -x. Everybody see what I'm doing? I'm doing the step 1, right? Step 1. Plug in -x. I just did it. I haven't given any logical reasons for this yet. I will in a minute. Let's first just learn how to do it. Step 2, simplify. How do we simplify? What is that part first off? -5 times -x. Well, what's the sign on that going to be now? 1 negative here, 2 negatives there. Negative, huh? We good. Negative. And then negative times negative, positive. So that's the simplifying. And then step 3, compare to original. Right? Compare to this one. How do those guys compare? Are you tracking with me? So step 3 is you make your decision. You look at and you say, okay, I plugged in -x and I simplified. Now, how does that compare to the original? Is it exactly the same as the original? No. Okay, so it's not even. Right? Even would be when you're exactly the same as the original. Okay, is it the original, multiply the whole thing by -1. -1 times the whole original. Is that what it is? That would make both these positive. No, one's negative, one's positive. No. So it's a mix. It's neither. This one's neither. Everybody see that? The function's neither even nor odd because it has an even part and an odd part. Turns out it's neither. Now, I know you might be thinking, well, can't I just look at it, Mr. Aaron? It's got an even part, odd part. You can try that. It's not, I mean, yeah, this one that worked out. There's other tricky things they can do. If instead of added, subtracted, the two things are divided, other more tricky stuff happens. If there was an easier way to do it than these steps, I would give it to you. I would suggest you just use these steps rather than trying to do some other tricky rule. Because they can be more tricky than this. So this will guarantee the truth will come to you. Other things may or may not work. Questions on that? Make sense? So that one's a neither. Okay, so try that one. You want to see if that one's even, odd, or neither? Look at that one. Try it. Try the little test thing. So step 1, plug in -x. Step 2, simplify. So that negative just goes away. Step 3, compare to the original. Original was up here. How does this compare to the original? It's the same. Even. Done. That quick. It's an even function. It's just x squared. All right, we good? Okay. Uh-oh, what happened? Come on. There we go. All right. So, okay, you guys have your graphing calculator with you? Let's type this into our graphing calculator. Use graph utility on the video. It's telling you the window, -2 to +2. See, it's saying right interval, that means x with x. Right? Interval always means x with x. That's your x min, your x max, huh? And approximate any local max and min. Determine, okay, they're telling you really specifically right there the window, aren't they? X goes from -2 to +2, y goes from -4 to 10. You'll get that window. So put that on your graphing calculator, get that window, and then basically they're saying which one is the right graph once you have that window up, and then it's also going to want us to find the local max and mins. Yeah. So first off, can you guys get that on the graphing calculator? And then if I could put it up too. All right. There we go. Can I borrow again a graphing calculator? Thank you. All right. So, all right. I'll try to show what's happening. All right. So what were those values? So it was this one. Then this was the answer. And what was the, so the answer is A. Here, let me erase that. The answer then is A. And this point here, the max. Somebody have that? What was the coordinates on that max? Minus 0.82? Yeah. 0.82 up 5 something? Or 5.01? 0.19? 09, okay. 5.09, okay. And then this, the min, the local min, was positive 0.82, right? And then what? 2.91. 2.91? Okay. So we found the max and the min. That's what they're going to ask us for. And then they're going to say, okay, now part B. Determine where f is increasing and where it's decreasing. Now, whenever they say they mean interval, so part B, they mean give me an interval where it's increasing. Let's start with that. So interval means what? X comma X, doesn't it? Whenever they say where is it increasing, where is it decreasing, they mean on the x-axis. The interval on the x-axis. So to find that, I say where. So if you're on the roller coaster here, where are you increasing? This section and this section, huh? Right? And so where is that? That's from -2. Remember, the window only went from -2 to +2. That's from -2 to, what's this? -0.82. Exactly. That's what we found here, huh? That's why that max tells you where it stops going up. Because when you're at a maximum, but you're at the top of the roller coaster, then you're done going up and you're ready to go down. Right? That's why that maximum is important to find where it's done climbing. So then it would be -2 to -0.82. And then also, comma, it goes from 0.82, right? This is x value, 0.82 to +2 because that's as far as the window went on that, right? And then where is it decreasing? Yeah, right in that middle. This is the decreasing section right in the middle. So that'd be -0.82 to +0.82. And again, increasing, decreasing, just use parentheses. Doesn't matter. Brackets are fine on the test. I don't care. Is that okay on how to do that? We good with that? Questions I can answer?
Is this supposed to be -0.82 or is it supposed to be 5.09?
Yeah, good question. The increasing, decreasing, remember, is x values only. Always x values. Yeah, so we don't use, all these are x values. We don't use any of the y values for those intervals. That's the easy thing. It's easy to get those turned around. So he's x's with x's when they ask for sections of increasing, decreasing. Other questions on that? All right. All right. So average rate of change. Average rate of change. What that equals, it is slope. It's a fancy way to say slope, which is y2 minus y1 over x2 minus x1. So it's slope. So basically they're saying, what's the slope of this function? Part A, from -1 to +1. So that means x1 is -1, x2, that was a big x2, x2 is +1. Those are both x values. Again, remember when they say from boom to boom, they mean x with x, don't they? Just like intervals. Those are both x values. So they're giving me two x values
So that'll, those will go down here. Here's x2 and here's x1, right? You got the double negative thing. Remember your slope function from algebra, right? Bless you. Right? And see how I get the double negative? One of them is the subtraction from the formula, and the other one is the fact that x1 is negative. Okay, so that's the bottom. How do I get the y values, the y2, y1? Plug them in, yeah. Because f of x equals means y equals minus 3x squared plus 5, doesn't it? That's the y value, right? F of x, function values are y values. So y1 will equal minus 3 times x1 squared plus 5. Makes sense? I just put in x1 to the function. Work it out. What's that? Minus 3 plus 5, 2. And over here, y, so that's y1. y1 will be 2. And then y2, put in the positive one. And y2 will be minus 3 plus 5. y2 will also be 2. Everybody good with that? So that slope, which is average rate of change, is 0 over 1 plus 1. So that's 0 over 2. That's 0, huh? So the answer to part A is 0. Got to do the same thing in part B, same thing in part C, right? So part B, you'll start again with y2 minus y1 over x2 minus x1. But the 2x values this time are going to be minus 2 and 0. So this will be 0 and minus 2. Then you plug them in to find the y values that go with that, subtract them, and do the same thing. So average rate of change is slope. We talk a lot about that in calculus, well, kind of, in the beginning. So that's what they're getting at. That's those two parts. That's all I have time for. Let me run. I'm supposed to do roll. It's like my job. So let me do that.